Hello, in this lesson we are going to talk about the graph of base function y equal x squared and the graph of the transform function y equal ax squared plus k. As you can see, the graph is in brown, which represents the graph of y equal x squared. If I turn on the graph of y equal ax squared plus k with a equal to 1 and k equal to 0, this means that a is 1, so it's x squared, plus k is 0, so it's going to be the same graph as the base function. And you can see that it becomes blue. Now, what will happen if the value of k becomes positive number and gets larger? So if I move this slider to the right, you can see that the graph, the blue graph, starts moving up. When I move it down to a negative value, you can see that the graph of the base function moves down vertically. So the conclusion here is that the k value, the constant, represent the vertical translation or movement of the base function. Now, when k is positive, the graph of the base function moves up. When k is negative, the graph of the base function moves down. What will happen if a value changes? Let's change a to a number greater than 1. If I move the slider to the right, you can see that as a increases, the graph of the base function is going to be stretched vertically or compressed horizontally. So when a is greater than 1, the graph of base function is going to be stretched vertically or compressed horizontally. What will happen if the value of a is, let's say, a negative number? Let's say negative 1 or negative 2. You can see that the graph of the base function is going to be flipped, or is going to be reflected upon the x-axis. If I change negative 2 to negative 1, you can see that this graph is a reflection of the base function. So when a is negative 1, the graph of the base function y equal x squared is going to be reflected upon the x-axis. What will happen if a becomes less than negative 1, meaning the slider goes to the left? You can see that still the graph is going to be stretched vertically and compressed horizontally, although it has been reflected because of its negative value. What about if a becomes a number between 1 and negative 1? Let's say 0.5. You can see now that the graph of the transform function is going to be a compression of the graph of the base function y equal x squared vertically. Or the same way you can say that it has been stretched horizontally. Now let's talk about what will happen if a is between negative 1 and positive 1. Let's say a is 0.5. You can see that the graph of the base function has been stretched horizontally or compressed vertically. What about if a is negative 0.5? You can see the graph of the base function y equal x squared has been flipped or reflected upon x because it's negative a, and also because it's 0.5, it has been compressed vertically or stretched horizontally. So in conclusion, if a is negative, the graph of the base function is going to be reflected upon the x-axis. If a is greater than 1 or less than negative 1, the graph of the base function is going to be stretched vertically or compressed horizontally. And if a is between 1 and negative 1, then the graph of the base function is going to be compressed vertically or stretched horizontally. So, in general, for any quadratic equation of the form y is equal to ax squared plus k, value of a tells us the orientation of the base function y equal x squared. If a is greater than 0, the parabola looks like opening upward. If a is less than 0, is a negative number, the parabola is reflected upon the x-axis, and we say it opens downward. If a is between 1 and negative 1, then the parabola is going to be compressed vertically compared to the graph of y equal x squared. If a is greater than 1 or a is less than negative 1, then the parabola is vertically stretched relative to the graph of y equal x squared. The value of k tells us if the vertical positioning of the parabola going to be upward or downward. If k is greater than 0, then it means that the parabola is going to go upward, and if k is less than 0, then it means the parabola moves downward. The amount of movement depends on the value of k. If k is positive, then it's going to move up k units, and if k is negative, then it's going to move down k units. For the quadratic equation y is equal to a x squared plus k, the coordinate of the vertex is given by 0, comma k. This means that the coordinate of the vertex, the x value of the vertex is 0, and the y value of the vertex is going to be k. The first example says for the quadratic equation 3x squared minus 5, describe the transformations first. When we look at this one, we see that a is equal to 3 and k is equal to negative 5. This means the transformations are, first, a is positive and is greater than 1, so we are going to stretch vertically by a factor of 3. And since k is negative 5, we are going to move the base function, the graph of base function, 5 units down along the y-axis. The next part says identify the vertex of the new graph. The vertex is going to be 0k, which is 0 and negative 5, and then graph the function. To graph the function, we are going to use table of values. So our table of values, the first point is the vertex, which is going to be 0 and negative 5. As usual, we are going to find the y-intercept. The y-intercept is the constant, which is negative 5. So we are going to say 0 and negative 5 is going to be our y-intercept. So the vertex and the y-intercept is going to be the same point, 0 and negative 5. Now we are going to find the x-intercept. The x-intercept is when y is equal to 0. So we have to solve this equation. 3x squared minus 5 is equal to 0. Move this one to the right, so we get 3x squared is equal to 5. Divide by 3, we get x squared is equal to 5 over 3. Then take the square root of both sides, so we get x is plus or minus square root of 5 over 3, which is going to give us plus or minus 1.3 approximately. So we know the x-intercept is 1.3 and 0 and negative 1.3 and 0. These are the x-intercepts. Now
Usually we need more points, so I'm going to pick two other points. Let's say if x is 1, then 3 times 1 squared is 3 minus 5 is negative 2. And when x is negative 1, negative 1 squared is going to give me 1 times 3. 3 minus 5 is negative 2. And this is enough. We have 1, 2, 3, 4, 5 points here. Now I can go ahead and plot the points on the graph. So the vertex is 0, negative 5. So this means that the vertex is going to be this point here, negative 5. The next point is 1.3 and 0. 1 is here, so 1.3 is somewhere around here. And the other one is negative 1.0, and which is going to be around here. So these are 3 points. The next point that we found previously was 1 and negative 2. So 1 and negative 2 is going to be here. And the last one is negative 1 and negative 2. Negative 1 and negative 2 is going to be somewhere around here. Connecting the points through a very smooth curve is going to give us something like this. And as you can see, the graph opens upward because if you remember, A was 3, so it opens upward, and because of K was equal to negative 5, so the base function was moved 5 units downward, which is this point. So the vertex has been moved 5 units downward. In this example, we have been given 3 different cases of a transformed y equal x squared. The dotted one is the base function, and the second graph is the transform function. What we have to do is to find a and k. For part A, which is this one, you can see that the vertex has been moved up 3 units here. So I can say that k is equal to plus 3, a positive number. And I can also say that the graph has been, the base function has been compressed vertically. So A is going to be something between 0 and 1. That's the first observation here. For B, we can see that the vertex has been moved 1, 2, 3, 4 units down. So I can say k is negative 4. And also the graph of the transformed function, which is this one, has been stretched vertically. So this means that a is greater than 1. And it has to be a positive number, obviously, because it's not flipped. And for the last one, this one, I know that the transformed function, which is this one, has not moved at all, so k is equal to 0, but it has been flipped, so a is negative number, but it seems to be almost the same as the base function. So I can say that a here is approximately equal to negative 1. In the next example, we have been given a graph of a parabola, transformed parabola, and we are supposed to find the equation of the parabola in the form of y equal ax squared plus k. To find the equation, you notice that the vertex is approximately here. This means that the base function has been translated or moved up about 6 units. So this means k is equal to 6. So automatically I can write that y is equal to ax squared plus 6. To find the value of A, pick any points other than the vertex that you just picked, which is here, and sub it back in the equation. Let's say I pick x is equal to 2 corresponding to this point, which has the value of y equal to 5. So I'm going to say when y is 5, x is 2. So a times 2 squared plus 6. I move 6 to the left, I get 2 squared is 4, so 4a is 5 minus 6, which is negative 1. So a is negative 1 over 4, which is about negative 0.25. So from here, I get that the equation becomes negative 0.25 x squared plus 6. So this is my approximate equation here. Now you can go ahead and check to see if this equation that you found is correct. Let's say I pick x equal to 3 here, corresponding to these approximate points here. When x is equal to 3, I get the y value. Y is negative 0.25, 3 squared plus 6, which is negative 0.25 times 9 plus 6, which is approximately equal to 3.75. If you look at the y value here, is about here, which is approximately correct because we have 2 points here. One is very close to 4 and the other one is close to 3. Again, remember, this equation that we found is an approximate equation. It is not the exact one.